Hi everyone, my name is Roman Ivantsov. I'm a software architect with Thaler Technologies. It's a company whose business is ERP systems for government. And today I'll be presenting you Irony. It's an open source project. It's about 2 months old. It's hosted on the Codeplex. And so let's get started. I have only 15 minutes, so I will be kind of rushing through things. Oops. My keyboard doesn't work. Excuse me, my keyboard doesn't work. What did we do? What? Yep. Okay. Thank you. So agenda, we'll be talking about first some introduction background, then second I will run some demo, show you simple expression grammar, how I parse it. Then we'll look inside Irony, what's there, a little bit overview, and talk about some future plans. So Irony is a project whose goal is to build a compiler construction kit completely in .NET. Quite ambitious goal. It's in initial phase, it's about so far scanning and parsing. Front end of the compiler. So what's with the name? Certainly mocking the name of language products from a well-known company, but also acknowledgement as the inspiration. Without I and Python, that probably this thing would never get started. And I and Python show that it's doable, it's possible. So motivation. Around a year ago or so, I started entertaining the idea of implementing my own language. Well, who didn't? Probably each programmer at some time in his career thought about this. So I decided to first look around, what do I have for implementing at least parser, scanner, all that kind of stuff initially. And what I saw was quite discouraging. It was quite complex. It was quite a learning curve and quite a high initial barrier to pass. And certainly, like any normal programmer who is too lazy probably or too stupid to learn some new tool, well, he blames the tool and decides to write his own. So that's exactly what I did. But seriously, what I saw is mainly all these compiler construction tools seem kind of outdated and dating back from original Lex and Yak things that were introduced in the 70s and didn't change much, seemed to me. But the worst thing was that it seemed to me that the code that they produced didn't seem modern. You know, it didn't feel like a .NET code, even when they were generating .NET code. All these huge switch statements, all these statement switches, go-tos, and so on. It didn't feel like .NET code. So I decided to investigate, can it done better, and probably to see. So the goal was to make it easier and make it faster. One thing that I noticed that probably, especially the Lexing part, was quite suboptimal in many of the implementations because on every token produced, on every character advance, it was so many things going on that were probably most of the times were thrown away because it was kind of moving forward one character and suddenly all this accounting for line feeds and so on, and lots of things were happening. So feature set, whatever Lex and Yak can do. Well, that was my basic goal as feature set. And method, try to do everything in C#. BNF is probably enough things to learn and no other grammar meta language. So probably as domain-specific language right inside the C#, using operator overloads. Second, no code generator. I personally don't like generated code, as probably many of us do. And to use one universal parser to parse any language the same way as Lex Yak do. And scanner construction, probably not as a finite state automaton, but more like a collection of standard and non-standard terminals, the same way you construct the Windows form from standard and non-standard controls. So now I'll run some demo and show you in action what's going on and how it works. Using a simple example, grammar for arithmetic expressions, I will show you Grammar Explorer and some other sample grammars. Oop. Where's my tool? Okay, this is Visual Studio, which you don't see. Okay, now you see it, and what I opened is the file where I try to define the grammar for my arithmetic expressions. What I need to do to implement a parser that parses simple arithmetic expressions which recognize 4 operations, numbers, variables, and parentheses, and correctly understands the operator precedence. So here is the BNF formal BNF expressions for the grammar. So what I do, I define the class derived from the standard grammar class, and then proceed and define everything directly in the constructor. So first I start defining variables that I will use using standard classes defined by irony. It's first terminals, 2 terminals, which are already there defined for number and variables, and then I'm preparing non-terminals. The next step is defining the BNF rules as they are in the BNF. And as you see, I'm using directly the same operators that more or less that are in BNF. And this is achieved by operator overloading on these classes that I use. You see also I can mix my specific classes with strings directly, and it all works okay, except in one case where I have only string expressions. So I have to wrap the first string into a specific call which explicitly tells the compiler that this is turn it into a symbol and then proceed with this expression. So each non-terminal has the property called rule, which is actually expression that defines it. So the result of all this is I build the actual expression tree, and finally my root of my grammar is assigned to the root property of the grammar. That's the entry into the grammar, and Irony's parser will be able to reach all the elements inside that I defined there, and infer all the dependencies and connections between them. So next, I'm proceeding with defining operators and their precedence, and then also associativity of the operators. Additionally, I defined, there's a little convenience. I say that a parenthesis is a punctuation symbol and remove it from the output tree. As for how to use this, and that's all you need to build a parser for arithmetic expressions. So now you are ready to use it, and you see how you use it. I provide the example in comments. You create the grammar, instantiate the grammar. You create language compiler, which actually a container for parser, scanner, and for everything, and provide it with the grammar. And then proceed just with parsing. You pass the expressions, and it returns the tree. We can see it in action using a helper application I created, which you see it opens in full screen, which is called Grammar Explorer. It shows you the grammar you defined and all the internals of this grammar. First, I will switch to our expression grammar that we just defined. It shows you all the terminals, all the strings, string literals that I defined in grammar. They actually internally converted into terminals, and are shown here. Then you have non-terminals that are defined there with their production. Then the full list of productions and details on the productions. Then you see the list of parser states. This list is certainly the most interesting page for language designer, and so on. There is a page for grammar errors. It's for parsing conflicts that you detect. And finally, the parsing test. So I will load the expression sample and try to parse it. So it did, and on the right you see the different number of tokens, the time it took. It's actually a lot less, 16 milliseconds. and the output expression tree. And as you see, everything was parsed correctly, including operator precedence and associativity. So, for example, the double power expression was parsed that it's first the second one and then the first one. So associativity is right for the expression. So let's. This is this sample. This is the real application that can be used to explore grammars, and I provide several sample grammars for other languages. One is Steam. So as soon as you select the grammar, you can see all the information about the grammar, and there are a couple of errors, unresolved conflicts. So, and this is shift-reduce conflict, and as we know, ladder parser will choose shift over reduce. You can try to eliminate this by tweaking the grammar. So we can again load the sample. I use 99 bottle samples from one site which publishes all samples in all different languages. About these 99 bottles, I can parse it and get the output. I also have grammar for Python, which also has some errors. We can look at 99 bottles in Python and parse it. And for Ruby, same thing. Okay, I actually loaded. I have two samples. One of them is correct. Another one is with errors. And I'm trying to parse it, and it shows me errors. This actually demo for error recovery, so that error messaging. First, parser reports the message. Second, it tries to recover and continue parsing. So you see it correctly detected different syntax errors. For debugging, you have different tools. You can see the parser trace if you need it, and the token list. Once you enable this, you see all this stuff. You can see the output of the scanner on the right. Yeah, and on other tabs, you can see how the parser actually proceeded with this. So this probably concludes my demo. We can also quickly have a look at Ruby grammar. So it's, again, following the same pattern. It's one file. And you use you declare terminals, not terminals, and then you specify expressions. This is not a real grammar that can be used to parse real programs. I just picked some grammar on the internet and thought that this grammar can be actually used for this particular parsing method, which was not true. I had to tweak it a lot to get rid of most of the parsing conflicts. And it still has. But simple programs, it can parse correctly. So let's go back to my presentation. Okay, now let's look at irony architecture, internal architecture. So traditionally, parsing is implemented in two phases. First is scanner, then which takes the source stream and produces tokens, which then feed it to parser, which produces the AST tree. Irony adds a twist here. It allows you to insert special token processors in between. And we'll talk about these token processors later. They actually operate on token stream, and they can remove or add tokens, performing specific tasks on the way. So all these classes, at least scanner and parser, they are standard, and they are not supposed to be overridden or created something custom from this. All custom information about the language is encoded in grammar. What happens at runtime, at initialization time, Irony takes the grammar, builds all the necessary information, all these transition tables, go-to tables, and so on. They are encoded slightly differently inside in the state graph and produces the grammar data. It also grabs all terminals that it can find inside the grammar and creates the list and gives it to the scanner, which actually, using them, the list of terminals, it performs the scanning and producing tokens based on it. Let's look at more briefly at each of the pieces. So first, grammar, it's just the base class with a lot of overloaded methods. C# overloaded are defined in BNF element, which are used inside the grammar, and all the standard classes like terminals, non-terminals are derived from BNF element. And there are helper methods for different clean operations. So you can say my terminal dot star, dot question mark, or dot plus. So in this way, this is essentially, it implements embedded DSL domain-specific language inside C#. Scanner. This is kind of this is not Lex style scanner. It doesn't use regular expressions. It doesn't use finite state automaton. This actually looks more like a Windows form with controls. So each terminal is actually a class which is provided to scanner, and scanner manages the terminals that it has to parse the source stream. So what happens is at each position in this source input, scanner simply calls the terminals it have and asking them, okay, at this position, try to produce a token. And whoever returns the token, and if more than one, then it picks the longest one, that's the winner, and it passes it through to the chain. There is some heavy optimization here, and one of the things is there is a lookup table, so each terminal can actually define prefixes which can start the first symbol, actually, which can start the terminal. So the scanner doesn't need to run through all of them, but to look up by this symbol. So, for example, numbers have digit character as the first symbol always. So each time, so this table, this lookup table, optimization table, it's built at initial time, and it results in huge performance improvement. Another thing, what does the scanner? It does ignore white space, new line, all that kind of stuff. So even for indentation-sensitive languages like Ruby, or indentation and new line-sensitive languages like Ruby and Python, this information is completely ignored, but it's not completely lost. So actually, scanner provides each token with information about line and column. And so this information can be recreated later, only if necessary, in a specific token filter, which we come to right now. So it's some specific processor between scanner and parser, and they can alter the token stream. So for example, they can perform the following tasks. And this actually helps to separate the code which is responsible for different functions, and provides much better layered architecture overall. I forgot to mention that actually the entire pipeline, how this scanner, token filters, and parser, how they are connected. They are connected as C# iterators, which makes it much easier to write specifically token filters, which are actually maybe custom written. So it introduces some high pseudo-parallelism in the code. So you, at the same time, your code executes in many different places. Okay, next. Parser LR1 algorithm, the same as YAG, controlled by state graph. Now, the resulting ST node tree can be completely custom. So you actually specify what happens at reduce action in parser. Is it creates the node specified in the non-terminal, the node type. So the language implementer can create his own node types for each kind of node, if node, function node, whatever, class node, and then provide it into corresponding non-terminal. So Irony will instantiate this non-terminal and provide all child nodes to it, so it can be initialized correctly, and the entire tree can be built in this way. And there are different customizations points already there, so that you can create. There is a factory method that actually, instead of providing a single type, you can also your method, your single method can be called, which should create the actual node. And there are some other public events and overridden methods in grammar that just for this, created just for this. So, summary and highlights. It works. Looks like. it seems to me it's easier to use than Lex and Yak. And one surprising thing, sort of, is high performance. It's actually between 10 and 20,000 lines. I didn't run actual benchmarks. What I did is just parsed 1,000 lines of Ruby code and try to parse into the Grammar Explorer, try to parse it, and it shows that kind of performance, which is kind of impressive, I think. With this architecture, I think you can achieve quite high code reuse and code quality. So you can use reusable components like terminals. You can use standard Irony's number terminal or identifier terminal, which you can slightly customize. For example, you can specify what kind of characters you can use in the identifier and so on, what kind of numbers you can generate. And the main point, no generated code. It's all in uses the code either which is in Irony or that you write yourself. So I think maintainability is much higher in this case. So, future development. It's in alpha preview release. I'm working on completing features for first release when it's actually usable, and all these kind of things that I implemented. And the next step is build runtime, and probably I'm targeting extensible object model. It's all about different object models that can be actually used at runtime. And these are two folks in Viewpoint Research Institute. They published very interesting paper called Extensible Object Models, and they claim that this simple model can cover different class models or object models for different kind of languages, including multiple inheritance and prototype-based object model for JavaScript. So I'm looking into this type model. Yes, I'm gonna use wrappers. So unlike some other implementations, I think wrappers are useful for even for simple values like integers or strings. And my personal opinion is that .NET types are not enough. I'm still looking at simple scripting language for testing, but I didn't make my choice yet. So that concludes my initial presentation, and I have the second one for which I have only 5 minutes. So shall we take questions now or after the second one? Let me proceed to the second one. Yep. I cannot be, I'm not sure about tomorrow for personal reasons. This is my second talk, although this should be actually my first part, which explains my interest in creating languages or creating tools for creating languages. But I thought that probably Irony would be more interested for you for language builders than this kind of stuff. So, ERP, that's where I'm coming from. That's what I'm doing for living, actually. ERP stands for Enterprise Resource Planning Systems, which is a bit misnomer, but for historical reasons. What actually it means, it's a system that serves all departments and handles all business in an enterprise. It means that everything, literally, what sometimes is handled by different systems, disparate systems with many databases, it's all put into one system against one big database. So these are huge systems, code base, number of users, and cost. They are very, very expensive. They are very expensive to create, very expensive to launch, and their service time is very, very long, more than 10 years, definitely for 20 years. And this kind of special things they bring, they have some consequences, definitely. The biggest challenge in ERP systems that no two businesses are the same. Unlike users of other traditional consumer-oriented programs, here we have every user, every customer is unique. And when you tell them that you probably change to do things that the way system does this, they say, no, this is our competitive advantage, the way we do things. We are successful because we do things this way. So your system should do it this way, the way we do things. So as the result of all this is every system installation goes through extended configuration and customization, meaning programming directly on site and changing the system code, how it works. So some facts. 3,000 configuration tables in SAP ERP system, one of the biggest one, I think the biggest one, the biggest vendor. And licensing fee, it means that what you pay for bits, what you pay for the original CD is only 30% of the original cost. The rest goes for configuration and customization, which can take years. So ERP implementations, complex, costly, risky. Sad facts. US Navy ERP project, $1 billion was spent on an effort to create several ERP systems to optimize some of their operations. When they went live, they failed to show any value for Navy. They called it pilot and said that, oh, no, we just tested. We are actually starting a new system that will go into production in 2012. Yeah, but this was a good test, but Government Accountability Office didn't agree with them and said that money was wasted. Hershey's spent $112 million on ERP system, rolled it out stupidly just before the Christmas season, and embarrassingly it ended in disaster when they didn't ship orders for their products, and although their warehouses, their stock was 30% up. So the Hershey Kisses was sitting in their warehouse just because they didn't process correctly orders. They get lost inside this system. So they had to roll it out and go through all the embarrassment and losses. Foxmeyer, a company, so they actually failed bankruptcy because they claimed because of failed ERP project. So, and list goes on and on and on. One thing, so it's risky really, and a lot of money involved and a lot of money wasted, a lot of problems in this area, and that's why I'm talking about this here, actually. So causes of failure, they are usually, you blame management, you blame technicals, programs, financial, and so on. But I would suggest that it's inadequate language in which these things are developed. And that's why I'm talking here. I would like to drag your attention to this area. It's out of spotlight. It's out of all the glory of all these flashy web pages, cool Ajax stuff, and so on. They are usually considered really boring, debit, credit, purchase stuff, 10 things of this crap or whatever, approve here, approve there. No fancy stuff, no challenging. But it turns out that it's extremely difficult to actually make it run, especially for bigger enterprises. And a lot of money involved, and I think that this size and its economic importance, they justify the attention that we finally have to look at this, how these systems are made. Maybe something is wrong with how we make them. I'm afraid to. So let's see at ERP structure. It's modular structure, as they call it, and it's many modules. Each of these modules, it's actually millions of lines of code. The basic characteristic feature is a central database, one big, huge, enormous central database, and in the center there's general ledger. It's financials and accounting. It's everything you do in an enterprise actually ends up somewhere on your balances and in your accounting. So general ledger is in the center, and there is a very high, don't show it as arrows, but there is a very high dependency and connections between modules. The thing is, by the way, the programmers who specialize in programming these systems, they have a kind of lifetime career devotion, or career is the whole time career as a programmer is associated with a particular model. So there are programmers that do only payroll, because the system, or for example, only fixed assets or accounts receivable. So when you hire consultants, it's not simply you hire consultants for SAP. You have to hire consultants for specific modules that you have that can do this thing. So as you can guess, they are very expensive, $500 an hour, something like this. Yeah. And the bad thing is also is that your programmer that does this thing must be as competent as your best business user of all this thing. So that's another thing. So he must be a competent programmer and actually know the business very well, and also know all quirks and faults and of your system, how it works. So how it's done actually for big systems. So it's multi-site distributed development model. Software vendor, original vendor, ships the entire source code, which gets not directly to the customer. Usually it gets to independent service vendors, which do many things to this code. They localize, they provide custom models, they provide country-specific modules, again, adding millions lines of code. And then they package all this and they sell it to a particular company, which hires a gang of consultants that for several years will customize this right on site on the and configure and so on. So what language do they use? Nothing special. If you think that there is some really fancy stuff there for this particular environment, the thing is, no. It's languages that originated somewhere in 80s. I provide their names. They look like Visual Basic sort of thing. Some of them procedural, some of them object-oriented. Distinguishing feature, they have all link-like data access support directly in the language. And how they do multi-site development that I just described on the previous page, mainly directly overwriting the code. So what they get, they directly go to the source code and start modifying it most of the time. And of course, all this mess after the vendor provides the upgrade. So what you do, you are screwed. Yeah. So what can be done better? That was my question when I really started looking into this and started thinking what can be done better. And actually, a lot of people trying to think what can be done better. And I'm actually asking you guys. I'm not a professional language developer. And I probably don't know much about some exotic, esoteric languages that are there. I know some of them, some of the features. So I'm trying to guess, and I will not provide you the ready to plan for a new language, but I will probably try to mention some features that I find in some other languages that might be probably useful in environment like this. So here's the basic list, and I will go through this in a little bit more details in the next screens. So code openness. Things like, for example, in order to change the class, you don't need to get into this class source code. Like you have, as an example, in C#, we get partial classes, but they all must live in the same assembly. What about if they live in different assemblies? Something like this we have already in Python and Ruby, I think, when you can modify the existing class from outside the place where it was originally defined. Second thing, which actually frustrates me often in traditional languages, enumerations, very useful thing. You cannot extend them. Once they are defined somewhere, you cannot extend. So, and what you have to do, you have to go into the source. But what if the original vendor defined these 5 document types and I have 3 more? And what is different is just slight alterations in some places. I want to define this, extend this enumeration, and I want to define some extensions to existing switch statements in the existing code. There is nothing like this in existing languages, no such concept. Multiple type dispatch, of course, should be there by argument types enumeration values, I think. new built-in dependency injection. If I redefine some class, I say my invoice is this invoice derived and so on. Then I want to code in my ERP system to understand this and create my invoice type, but not the original one. And of course, private public modifiers, they are no longer important. Outright rush. Processes and communications, persistent continuations. So the question is, why can't I code the long-running process the way I code a wizard, simple wizard, which asks user a question and changes the screens for him? Oh no, if it's on the server or if the user will respond in a day or two or in 2 weeks, then you cannot do this. You cannot hold the process active on the server. What you do, you create actually a state machine, and you have to save your state and resurrect it after this. And all this workflow stuff is actually there, helping you to create the state machine in some fancy way in Designer. Well, what I suggest, probably a more transparent model and more native model and natural would be just to create persistent continuations when you stop at any moment and say, okay, I'm waiting for user response. So system takes the continuation at this moment, hibernates you to disk, and then in 3 days when it gets response, it resurrects you. Built-in messaging, long receive. And that's a good point, because at the moment when system or language environment says receive, it understands now we are waiting for message and we can wait for days or weeks. So we can safely hibernate the whole process, the whole thread. OS threads, error handling, scheme conditions, when I can actually, what we have in .NET is catch block, which is executed after the system unwinds the call stack. It's too late to fix anything. What about if I can provide the code to execute immediately when the exception happens, and probably I can fix it. I can provide the code for fixing it. Object model through message passing in AOP style, so I can intercept it from anywhere in external code when some method is called. Change events for properties. Right now, if I want to sign up to watch some property in the object when it changes, I'm at the mercy of the original programmer. Did he define event or not? This must be available by default, I think. Which brings me to my next point, data binding. If you have this type of things in the language environment, then you have data binding. You can bind without saying that provided you have certain interfaces implemented by the object. You can bind everywhere. Transaction support. We have transaction support in databases, but not in the language. So, and it brings a lot of mess, and a lot of code is written just to support what to do on rollback and how to correctly roll back the values. Lazy evaluation, of course, and indestructible virtual objects. For example, obligation. It's some object like you have specific ways to create a factory. What you do in C# to create an object. So you create a factory method and hide the constructor. So the object creation goes only through the constructor. So indestructible object is kind of the opposite. So the object can be destructed only through a special method. So the application is this. The problem what often happens is that mistakenly some program, some piece of code marks some things like purchase order as fulfilled or completed or whatever in the system. And so when it happens, it's actually quite embarrassing for the company. They lose the purchase order. What if we had a specific object called obligation, which is created as soon as customer enters the purchase order, and this object cannot be destructed, but it can be destructed only in shipment department, in shipment code. So when programmer tries to do something with the order, he cannot get rid of this object. He can either pass it to another object, but it continues to live until it's destructed somewhere in only specified trash can, sort of. Authorization framework. Well, a lot of code is spent written to support this. That's why, by the way, almost all the data binding things that you have okay. So this is something has to do with security when the system supports automatically blah 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 blah. Version customization. The main thing, raise the abstraction level. So what we need, the code ages very quickly, and I have to change focus from productivity to maintainability. So no more productivity talks. Your productivity goes through the roof. I feel like a brain surgeon who's approached by a salesman. Hey, dude, with this thing you can cut twice as many brains as before. You know, yeah, I have a better tool, chainsaw. So is this the right message? Probably not. Yeah. Well-being of the patient, you know, quality, whatever, but not productivity. You know, I'm not a guy with a shovel. So the code lives too long. It must be maintainable and extensible, modifiable, reliably. So I welcome everybody to look at the systems. There are huge problems, which will just so many things to do. New language is needed. That's why I started to look at if I have to create a new language. So how I do this, and that's ended up in irony. That's the first step. It's a playground for creating new languages. And new economic, ERP economic impact is huge. So if you want to make a difference, that's a good place to start. Thank you.